going to wait about another 2 or 3 minutes here.
I know at least one more person.
And some stuff out. I tried to put um out the notification a little earlier, but I was having difficulty getting Canvas to send the notification. So I went ahead and just sent it via email directly to everybody um, over Pathway, and something I hadn't done previously. So I see a couple of familiar faces. I have a couple of you who are going to be coming in from my uh, um, online at the moment. Um, if you can go ahead and just use in the reactions, um, just use the thumbs up gesture if you have previously taken ISL 5565.
Was that the stat learning one?
Yeah, that's statistical learning. If you've taken pattern recognition as well. Okay, I'm watching all the thumbs go up, so it looks like we're in pretty good shape as far as that. For those of you who have taken that class, you may the uh, a little bit of the introductory modules may seem like they have some overlap, but I'm going to try to go into a little bit more detail on some of the items that we covered in a very cursory fashion initially, because this course is going to focus extensively on an understanding both like conceptually as well as fundamentally when it interacts with and interfaces with neural network systems or adaptive neural network systems. So all right, everybody, let's go ahead and at least get started for this evening. Thank you all for coming, being present with us. I am going to do a couple of things. First, we have obvious housekeeping. I want to talk a little bit about the general direction of the course. I try to keep things relatively symmetric as far as grading throughout most of my courses. So if you've taken a class with me thus far, you'll kind of see the same breakdown for graduate classes. It's kind of a kind of a 2020 10 10 10 kind of framework. But we'll talk about that in a little bit. We are mixing it up a little bit because I tend to put assignments in this class just a little bit higher. They go up a little bit. So um you for those of you who are on Canvas and able to see the published version of the Canvas slides, you should be able to see the syllabus, but I'm going to go ahead and share my screen now. And we're going to go ahead and walk through uh, the initial aspects of the syllabus. Okay. Everybody able to see this? Okay. So this class is 5567. Its distinction is that of deep learning. It is a extended and modified version of a class that has been around for a good number of years. Previously, it had been offered by one of my colleagues, and also, to be frank with you, kind of one of my idols. He's my mentor during my PhD program. By the way, I'm Jesse Lowe, as you can see through my Zoom tag. I am a assistant teaching professor in School of Computing Analytics and Mathematics. That is a subsection, of course, that most of you are probably involved in intimately I teach primarily courses associated with machine learning, especially those that are associated with statistical and probabilistic supervised learning. Part of the reason why that is my forte is it has to do with my dissertation research, which was focused on biomedical and biometric imaging. A good chunk of those items that are associated with my research would be said to be image processing, but also sequential image processing systems. So I deal a lot with temporal and spatiotemporal metrics, and those are extended versions. I guess you could say they're very much a extended version of the paradigm of artificial neural networks. So that being a framework or required principle understanding that is necessary for advanced image processing that we'll start off with. And so we'll do a little bit tonight, hopefully do a little bit tonight. Maybe try to engage in a little bit of discussion. I hate Zoom for discussion. It's not ideal, but I try to open up some opportunities for you guys to be able to ask some questions if necessary. But as I mentioned beforehand, I did receive my PhD from UMKC. So I know what a lot of you are going through from the perspective of saying that it's very easy to sympathize. I've been on your side of the desk a lot, of your sitting in the chairs you guys will be sitting in for the classes, etc. So with those considerations in mind, understand that I do my best to try to be sensitive to your plight. So if you have something you need from me, be sure to reach out, talk to me about it. I'm usually pretty sensitive to challenges, etc. This particular class, I admit, is going to be probably a little bit more technically challenging for some of you. Part of that is determined by the complexity of the computation systems that you'll be working in. Many of them are that did not solve my problem with overexposure. My image is overexposed terribly. I'm having difficulty seeing my screen here. There we go. That's much better. One of the things that'll be difficult is initially getting some of the platforms we're going to be working with set up can be a little bit challenging. And oftentimes you're going to run into runtime challenges. So the first thing I will say is deep learning is probably a lot more accessible now than it used to be. I'm certain most of you have heard about this field and area. Largely, I would say that this is a advanced elective, is one that I don't usually have to provide a lot of structure and background for because people know what it does. But I will describe to you, at least in as high of detail as I can, relative to the syllabus information, those targets that we're going to hit when it comes to learning expectations. Now, when I say learning expectations, I'm really talking about what I'm effectively promising to provide you as part of the educator process. So if you need me by contact process, you have my email. I will establish some office hours. If we have anybody that joins the chat from now on, please make sure to mute. It's a little distracting. Give me just 1 second here. All right. Like I said, I will provide for you guys some course hours. Obviously, at the moment, I don't have everything nailed down for my schedule. It's very early in the semester. I'm assuming Tuesday and Thursdays probably will be a relatively decent time to get in touch with me. probably before this class, and then probably in the afternoons on Monday, Wednesday, and Friday. So that's kind of where I'm working with right now as far as my rough availability. I might have an hour or two that I can allocate to student response framework during that time. But as far as just being in my office during normal hours, I try to always make sure that I've got at least 2 to 3 hours a day during the regular week. But that doesn't always mesh perfectly with every student's availability. So if it doesn't mesh with you, I'll be happy to get in touch with you. We can start off with UMKC Connect if you need to. We can do Zoom calls, or I can usually provide you with some time that I'm going to be in my office that's outside of my designated office hours. But by the end of this week, I will update the syllabus to include my office hours once they're nailed down. We will be meeting in Florsham 310. I got the classroom for this class moved. It's a larger classroom space, so it should give us a little bit room to spread out. The enrollment for this class is relatively high. I think somewhere in the neighborhood of 70 plus students. So there's gonna be a lot of you. I have 2 TAs, so that'll be nice. And the effect of saying that I think that they will be able to be useful to you. I'm going to try to figure out how to optimize their resourcefulness for you in the process. Both of them have been students in my course as well as a previous offering of this class. So they should have an understanding of all kind of the prerequisites for that development as well. I would like to try to see if we could put together maybe some sort of supplemental instruction or maybe some supplemental lecture material, but typically that material will probably only be available for those people that either come to special sessions or arrange to be able to meet with the TAs. I don't think I will probably have core publications for that. So let's talk about course description. Everybody should have probably read this as part of the original enrollment. We start off with a discussion of neural networks and deep learning. Deep learning specifically being a branch of machine learning concerned with the development of applications for modern classes of neural networks. Now, the reason why we say that modern classes of networks largely focus on deep learning is most of the shell learning and peripheral learning spaces have split off into their own factious methodologies. Deep learning probably remains one of the most successful versions of a machine learning framework utilizing neural network technologies. And it is really the area that probably most of the advanced technologies are emerging from at the moment. So convolutional neural networks are largely utilized for image processing. They're also utilized for image generation, as well as making up a part of a lot of structural analysis tools for machine and scientific applications. What we're going to be doing here is we're going to dive into the computational practices. All right, that involves both the mathematical and principled computational methodologies that are involved in the construction of the principal elements of the neural network, as well as the tools needed for implementation of those deep structures. There may be options for those tools. I like to open up opportunities for students to be able to work in platforms where they're comfortable. All right, so in opposition to those of you who might have taken my ISL class where we were effectively restricted to the R language, there probably won't be any hard and fast rules when it comes to implementation decisions on your part. However, I may prefer to describe to you the implementations and operations in 2 different places. Okay, so this is the weird part. Some things are going to be really easy to describe and easy to implement in platforms like MATLAB, and other things are going to be really easy to implement in Python. Python's probably a little bit more versatile. So functionally and typically, I'm going to try and opt for, as frequently as possible, discussing in the most open source formats, such as Python, with popular implementations like TensorFlow via a model library called Keras, which is a acceleration methodology for uh, uh, a CUDA-based deep learning methodology. Now we'll talk about what I mean by CUDA methodologies and talk about acceleration methodologies a little bit later on in the process. But keep in mind, we're going to try and keep the hardware and sort of software installation requirements at a minimum. And we will also be trying to provide a workflow to describe for you how to be able to do most of the things that we're working on as part of the cluster environments via the Tux cluster. So we're getting some updates to the Tux cluster. I'm not entirely certain when that's going to happen, but I have been made aware that we have some additional funding and that's probably going to go into the acquisition of some additional modularity, such as more compute units, et cetera. But we should be able to still have some parts of that online operational. Most of the things we're going to do in the introduction of the class can probably be done on very easily and quickly. I think almost everything we'll do in the class will probably be able to be done on privately owned, commercial grade, consumer grade hardware. If you have like even the most rudimentary kind of graphics accelerator, you should be able to do general purpose compute on your graphics engine with most of these technologies. There are some restrictions to that. Typically, it's best to do those with NVIDIA-based technologies. I'm not endorsing a specific company. I'm just saying that the reality is NVIDIA has a bit of a corner on the market, and at the moment, where they're setting a lot of the standards for development in the same way that you could say that IBM set some of the standards for development during a lot of the implementation of early, industrial computing. So NVIDIA just happens to be the prime player, and they've gotten a lot of adoption by a lot of those common libraries, such as I discussed earlier, which are going to be the TensorFlow library, Keras, and also the PyTorch library, which is part of Facebook's open source AI development platform. So we're gonna work with some of those basic ideas. What we're going to need to have in order to make a lot of this stuff happen when it comes to the functional approximation and classification paradigms, an understanding of rough linear approximations. So we're going to have a introductory analysis. I'm not going to spend an inordinate amount of time on it because I feel like at this point in time, if you're not sort of on board with linear regression, maybe that's something you need to spend some time with on your own, and I will provide you guys with some supplemental material for that if you're feeling like you're coming up a little slack in that area. But a statistical learning class focusing on supervised and unsupervised methodologies is a requirement, a prerequisite for this course. 5565 or 5586, which is pattern recognition. That's the parallel course for the electrical track. Those courses are requirements. So if you somehow manage to end up here and don't have those requirements fulfilled, talk with me and I will help you prescribe a course of rapid remediation using some video series, etc., to try to get you up to speed so we make sure we don't have you falling behind early on in the course. As a result of that requirements, I think that the background matching between these other items are saying you need a background in calculus, you need to have an understanding of probability, you need to have rough chops in linear algebra. Obviously, you'll get a lot better once we go through some of that stuff here. And I do like to say this, if you don't feel roughly competent in Python, if let's say your primary functionality is Java or something along those lines, yes, there do exist parallels in Java frameworks. You'll implement a lot of these tools. Some of them have argumentation that they may be either better or worse at certain things. So If you don't feel comfortable in Python and you prefer to do it in Java, I'm good. Whatever, that's fine. Understand that the level of direct technical support for implementation level problems you might come across is not going to be the same, right? You go onto that jungle yourself. So if you don't feel like you want to transition into Python as something that can help you expand your vocabulary with respect to your ability to work with a variety of languages, which I don't recommend. I really don't. I feel like if you don't feel familiar in a language, don't get scared about it. All right. This is as good an opportunity as any time there is an opportunity to be able to take advantage of the chance to get some Python chops alongside being able to implement some of this methodology. MATLAB, I think if you're not at least roughly familiar with MATLAB, also be another situation where getting familiar with it is never going to hurt you. There's a lot of industrial applications that demand it in data science. I would say there are a lot of employers, especially like startups and stuff, tend to be drifting away from commercial solutions like MATLAB. But at the same time, there's a lot of advantages to it in strict scientific compute space. So we will introduce it, discuss it. I may do some demonstrations with MATLAB-based code, but I don't require you to have any personal licenses for it. You can access it all through university campus computing systems. So anything you might need to do in that space, you can do on those campus computing systems. They're not fast, not going to lie, but they're still workable if you have an understanding of what you're doing. Learning expectations. All right. So let me go to the next step of this process. This is where I'm talking to you about what I would like to be able to deliver at the end of this semester session. I'm going to read this to you. I put this together kind of as a consolidation of different ideas, drawing upon my own impressions and inference, what the goal of the course is. Everybody's probably going to have their own version of this, but I try to set up these expectations based upon what the goal of the class will be. We may have to adjust these, not going to lie. Some of them might have to reflow a little bit, but I think this is very much in alignment with where the direction is going right now. It says students will be able to demonstrate via evaluation and reporting. That is to take tests and to be able to generate some sort of like technical reports and outcomes, homework, etc. A comprehensive understanding of fundamental concepts underlying neural network-based feature extraction and pattern-based learning. All right, so that's focusing primarily on the two sort of scopes that we're looking at here, pattern-based learning and feature extraction methodologies, mostly including neural networks, activation function and backpropagation, as well as convolutional and temporal feature extraction methodologies, pooling, and the statistical inference methods that are utilized to take advantage of all of that stuff, leading into the sort of decision-making frameworks that are often at the end of these deep models. So deep learning involves a process mostly sequentially handing off through a series of modularized elements with use-specific tasks. So what we're going to be looking at is relative to those more advanced methods, students will be able to identify the processes necessary to implement those deep learning models within popular frameworks and architectures, like modeling architectures. There's several different ways to do that, as well as to adapt models and methods for use with a wide variety of data formats. Okay, so we're going to be thinking about how to build those models to work with data that can come from pretty much anywhere, right? So we're not going to be stuck with specific methodology. We're going to stay generalized enough to be broadly acceptable. Largely, that's going to be by doing projects and providing examples of methodology and implementation within wide scope space. Projects will be used to allow students to demonstrate mastery of topical understanding, including transfer learning techniques for specialization of pre-trained models. Now, some of you may have already heard about this technique. Transfer learning is probably one of the primary things you might do when you sort of get out of school, get out of college, start on with a company. If you wanted to do something as a machine learning engineer, You might take an existing pre-trained model that's been trained on a large corpus of data and then try to adapt its understanding to a specific use case. This largely has to do with the fundamental underlying concepts such as the bias variance dilemma and the no free lunch hypothesis. Now we'll talk about both of those within the next probably sometime this week. All right, so either today or on Thursday. Once we get those options in place, students will then be able to utilize appropriate vocabulary and topical understanding to discuss model performance, metrics and evaluation, and ethical considerations and challenges regarding the use of deep learning, including things like bias. All right, we're talking sociological and inference and systems-driven based biases. Fairness, right? That is the ability and accessibility of the model and its utility across different bases and different cultural paradigms. Transparency, that is the ability of the model to be understood, interpreted, and learned from, as well as privacy, right? So, as well, most of you probably understand this. Any of you who've taken classes in like data management and security definitely understand that the concept of privacy is a big issue. It is one that is not being really well dealt with right now when it comes to deep learning paradigms. Most of the time, you can find researchers that will show you that many of these deployed systems have significant vulnerability when it comes to the transparency as well as the privacy retention of most of these commercial deployed deep learning models. And I'm talking about things that are already actively used in commercial grade environments. All right. The last thing we'll do is we'll have an implementation project, which will allow you guys as the students to demonstrate comprehensive application of your deep learning principles, right? And to address some kind of complex problem, right? So something beyond the scope of a relatively simple, spatial solution, something that cannot be effectively handled at a lower degree of complexity with the level of performance that's desirable in that circumstance. Okay, so the key factor there is delivery will focus on utilizing your skills that you acquire through this course to address that problem. So it should work out such that everything that we do up to that point in time, as I begin to prescribe for you that final project, you'll be able to see how you can utilize what we've developed through that process to start implementing it. I have yet to decide, and this is one of the elements that I'm working on trying to figure out and facilitate. Once I discuss with my TAs, we'll be designing that scenario as well. I would love to have the opportunity to have presentations for this class. The only way I believe that it'd be possible would be to have group presentations, and that is not always the greatest. All right. I know you guys probably are familiar with that process. Some of you probably go, yes, I'd love to do a group project. And some of you go, not really so much. Okay. I can tell who you are already. Those of you who really want to do the group project are the ones who do very little. Those of you who don't want to do the group project are the ones that realize you did all the work for everybody else in your class the last time. Okay. So part of it is this. I want to try to make sure that everybody gets an opportunity to contribute. I want to make sure that everybody gets an opportunity to succeed. Partially, I would like an opportunity for everybody to learn from everybody else. But at the same time, this particular class probably is going to be a little too large to have presentations on a wide variety of topics. Ultimately, your final project will likely be very much or fairly symmetrical across the course groupings. There's not a lot of variation that's going to happen. So the presentations may actually focus on individual presentations, probably recorded, probably uploaded, and then evaluated by the instructors and TAs for the course. Okay. Attendance methodologies. Throughout the first few weeks of this class, usually through the first 4 weeks or so, I am going to collect some kind of attendance. Tonight will unfortunately probably be very difficult. I could probably just take some screenshots of who all's in the chat space and then go through and manually add you all up. That's always possible. But at the moment, that's little less than desirable. But why don't I go ahead and why don't I just go ahead and start off with that? I'll just do that. So everybody that's here at the moment, I'm gonna just grab a I'm just gonna grab a print screen on this here. So okay. Okay. I think I have everybody. Okay. Let's get back to it. Recording the class sessions. This is one of the things that's going to be a little difficult. I probably will record class sessions, but they may not be available to everyone in the course. It really kind of depends. All right. Partially the reason why I have this policy is that I note that every time that I record a lecture or I record a class, that my attendance drops to nothing. All right. That's not necessarily going to be helpful to you in the long run. So my usual reminder will be that if you are present in the class and you are sort of along for the ride with us participating, you're going to have a lot better experience. I am going to be adapting some methodologies to assure that process throughout the level. I'm going to be providing random quizzes either at the beginning or at the end of lecture sessions, or maybe somewhere randomly within. I found methodologies to do that on Canvas, and I found methodologies to do that on paper. That should work out pretty well for us. So those of you who are with us and involved, you're going to end up doing quite a bit better there. Now, partially that comes from the grade framework, grade breakdown here, right? So remember, attendance and participation are worth 10% of the class. In the past, I've kind of made this a little softer. In this class, I 100% mean it. If you don't show up to class, you're going to rapidly lose. Okay? The way that 10% works out, that does not mean that if you show up to 1 out of every 10 classes that somehow you're going to make it. That does not mean that you must attend at least 10% of the class. That means that attendance for this course is worth 10% of your total grade. Meaning that if I do not see that you have, let's say that I took 10 random quizzes throughout the semester and you did not take 3 of them, okay? That means that you're going to get 7%. So out of however many quizzes, participation, assessments, and activities that I put forward, that total number will be associated with attendance and participation. I probably will give a little bit of upper end on it, right? So I think as long as you're attending roughly 90% of the courses in the class, that probably will stick at the 10%. But if I don't see you except for test days, that's gone, 10%. 90% is the highest you're going to get in this class, period. I've had serious problems with attendance in the past. I've discussed it with everybody, including graduate advisors, including Coretta. She was so emphatic about the necessity for students to attend this class that she said she would personally show up to encourage you guys to show up to this class. Okay? I may get her to do that. It really depends on how things come down. Okay? So just be present, be involved, be engaged. I am going to try to do some stuff personally. I am a little bit frustrated with people being overly distracted by their digital devices. I'd still like to allow the opportunity for everybody to be able to engage with their technology. But at the same time, I've seen a lot of people who just get on Facebook and stay on Facebook during class periods. So I wanted you guys to try to stay as engaged as possible. If you're having attention and focus issues, talk to me, engage with me, ask some questions, talk about the topics. That should help fix some of the problems. Okay? Assignments will make up 30% of this class. All right? Assignments and submissions will be proof of work related, right? And they're going to rely on you to be able to appropriately explain what you've done with underlying logic and framework, okay? These may include programming assignments. They may include protocols and outputs for modeling methodology. They may include efficiency assessments, okay, to where you're taking a model and you're comparing its capacity to be able to work on a specific type of data, or you're developing a model utilizing a training methodology and then reporting on how well the model performed on that data, okay? That's where I'm really interested in, is your capacity to explain, provide proof of work that you have done what's included in this. Unlike other classes that I might offer at the graduate level, incomplete submissions or non-working submissions will not be accepted. They're zeros. Okay. It has to work. It has to do what it's expected to do. 90% of the time, the stuff in this class will have fairly specific sets of instructions on execution, but there will be work for you to be done. I suggest that you start at least reading through comprehensively analysis of any kind of assignments that I provide when they're provided. The goal will be that I provide you with at least 2 weeks of lead time on any kind of submission. So rather than the normal 1 week cycle that I have in other classes, I do a 2 week cycle on this one because they can be involved. However, the trap is that if I give you 2 weeks to finish something and you don't start on it till the night before, I'm expecting that you've had 2 weeks to work on it. Okay. So the assignments can be very difficult sometimes. They can be very challenging. So do not wait until the last possible second to start on that process. Midterm will follow a quarter of the class. Final will follow a quarter of the class. Notice, final evaluation is comprehensive. I don't need to further clarify that in the future in case anybody asks. My courses always have comprehensive finals unless otherwise distinguished. The reasoning behind it is I don't feel like something like deep learning, just like statistical learning, has any business having a final evaluation that does not say it takes into consideration the initial steps, because you will need to understand everything that came before this and remember the terminologies and details in order for it to make sense. We will have a final project that will also be worth 10% of your grade. If you don't do the final project for this class, it's not just 10%, okay? This is one of those weird aspects of the course. If you don't do the final project for this class, you may fail, okay? It's worth 10% of the total grade for full-scale assessment, but it is a required submission. The final project for this class will be submitted for you to pass the course. If you do not submit the final project, it does not matter what the remainder of your scores on the assignments for the rest of the work, you will fail the class. This is not my rule. This is the rule of the advisor of mine, my former advisor. As I said, kind of my idol who taught this class before me, who's passed on to me. I find it very important, all right, because I don't think that it is right for me as an instructor for this course to allow people to go out of this class with this specialization on their transcripts who cannot fulfill, who cannot complete that final project. All right. If you can't demonstrate your work, you can't demonstrate your competence in this topic space, then you don't deserve to be going around with that expertise of being a deep learning expert on your transcripts. All right. Here's the other side of it. My promise is that if you stick with me, I will show you everything that you need to know and get you up to speed so that whatever you do get to that process, that I will deliver as much as possible on helping you be able to say and be confident and competent when you go into an interview with somebody who's going to hire you for a deep learning job, that you're going to know your stuff. All right. So I know terminology is a bit of a problem for some people in this class, but we'll work through it. Okay. We'll work through it. I don't think it's inaccessible. Usually the way I work it is whenever I introduce a topic, the very first time I introduce a topic, I will define it. But then I'm going to feel free to use the terminology as it's used commonly in publications or other forms of media, right? So you're going to want to get it the way that you're expected to be able to talk about it whenever you go into the interview. If you have any questions about the kind of things that they can ask on interviews for machine learning, I have some really good resource topics on helping you prep for that. But they're also very daunting because sometimes they can even ask questions that I kind of go, oh, hold on a second. Let me think about that for a minute. because they really are trying to challenge you. They're really trying to see whether or not you can think outside the box, think on your feet. So I'm going to try as much as possible to get you guys whipped into shape to be able to make sure that when you go out for those interviews, one, you'll make sure you've got the right kind of tools to show with what you've got. Now, part of what I was talking about with the final project, and one of the reasons why I think that's critical, is rather than just coming to you guys and talking to you about, oh, how I'm going to hit you with a hammer at the end of the day, right? Everybody thinks that the grading process, everybody thinks that the assignment of work is focused on just trying to make sure that, you get the thing you're expected to do. No, not exactly. The goal is for me to provide you with what is going to help you get a job, help you be an expert, help you apply to break down the knowing doing gap of machine learning implementation. So if I provide you guys with this comprehensive final project and you put all the work you've done for it on GitHub, you put your results up, you put your project report up, and then somebody you apply to this job in data science and somebody goes, what have you done with it? And you say, hey, look over here. Look, this is a project that I did, real applications, real data with results, with comprehensive discussion of that paradigm. You're coming to the table effectively with some experience, some work experience in that space. Okay, so while it may seem a little daunting, while it may seem a little bit of a hill to get over, the goal of this class is for you to be able to have the tools, to be able to have the knowledge, have the skill, and be able to get the job at the end of the day, right? I think that's pretty much, at least I try to cover all my bases of what everybody might be in here for. Some people like to just know, right? They just love to know, and they'll go and learn everything. Sometimes I have to specifically encourage people to say, okay, this is going to make you money. If you're good at it, you get good at it, you can make the money. Okay. So that's what I will say is you can make the money with this. There is probably no end to jobs in this industry, especially with this high-end skill set within probably the next 10 to 15 years. I really can't perceive a space in which we're not having some level of advancing machine learning engineering jobs being pretty much the stable and reliable job space out there. We're going to utilize, so let's talk about textbook for a moment. We're going to utilize Ian Goodfellow and Yash Begnio, Aaron Corville. We're going to use a book by MIT Press that is called Deep Learning. Okay. So, amazing. Deep Learning, such an inventive title. All right. Part of the reason why they came up with that title was because they didn't want it to be hard to find. Okay. They wanted it to be easily accessible. At deeplearningbook.org, a full version of this book is available. Now, is it a PDF you can download? No. Partially that has to do with the fact that they have publisher restrictions with the way in which they're able to present that material. Okay. So the whole book is available in sections, including framework layouts of the introduction, applied basics, linear algebra, probability theory, all the subjects and topics we're going to go through. But what you're going to have to do is you're going to have to grab them on their own as individual subtopics. Okay. You can take these as HTMLs, and with the appropriate tools, you can drop these out to PDFs. I cannot. I will not. I will not make any changes to this book. Okay. You are free to do whatever you like. I may occasionally take figures. I may occasionally take quotes and information from the book, but I will not reproduce this in any other source. So you're going to need to go to this website if you want a copy of the book or book materials. I can't post it again. I can't repost it. But on your syllabus, you will see down there at the bottom, it says deeplearningbook.org as a note to the link. There is a print version of this book. It's not stupid expensive because they did make quite a few copies of it. There is both a hardback version and a softcover. I think the hardback is somewhere in the neighborhood of the $50 to $60 range. So if you need a hardcover or a paperback book of this, if that's your modality, you like to have a book, you know, kind of opened up and be able to see the pictures and everything separate from your screen, whatever else. There should be several copies of it either available from the library or from your favorite benevolent robot overlords at Amazon or eBay. You know, they're far willing to sell you one if you really want it. However, I will say, since it is so readily available, partially, I have a big interest myself because I hated buying books. Buying books is like, I'm not going to use this, okay? And truly, I don't. I don't really go back to my library a lot and go get books that I use for my undergraduate. Okay, a lot of them are old, a lot of them have been replaced, so I don't love them. But these digital materials make it to where the already astronomical cost of your tuition, I'm trying to mitigate that a little bit. I'm trying to save you all 60 to 80 to $100 by having a book that you can access online virtually. The other thing that I like about it is you can print it. They say you can print it all you want. You go to the library and print off the whole book if you felt like it. You can print a PDF from the HTML. Okay. So they don't restrict it in that way, but they don't have like one thing you can just put on your tablet. So if you're willing to do a little work, and you can get it on your tablet, you can get it on your desktop where you don't have to worry about being connected to the internet. But I just suggest taking this link, throw it in your link bar, and then whenever you need it for access to information, you've got your link bar up there at the top. Okay. We may have remote exams. It's always possible something comes up and we still need to get an exam done. There's always a possibility of going remote. What do you need, Cheyenne? No, you're good. Yep. No, it's free. It's free. If you go to the website, the whole book is free on there. The whole book. Yeah. So you won't get a PDF. Like I said, I'm trying to describe that very clearly to people. You won't get a PDF. The reason why you won't get a PDF is they even have, if you go to the website and you look, shoot, that's not it. No. I think I closed it. Nope, I didn't. If you go here and look and see, yeah, can I get a PDF of this book? No, our contract with MIT prohibits the use distribution because of certain methodologies are too easily copied, right? So effectively, the reason why they have it broken up into chapters and segments is so that it's hard for somebody to take this whole book and put it online somewhere else. I've never looked for it. All right. There may exist one compendium copy by PDF. Like I said, I don't even know that I would suggest that because they do update this. Okay. They do update this. This book has been updated several times and has constant errata that have been pushed into it. So this one shows errata in the published editions. All those errata are integrated to current copies that are in this runtime. So whenever you click on this and you're looking at this chapter that shows contents intro, this is an actively updated HTML page that shows this contents reflected via whatever the most recent changes the authors of the textbook have made. Okay. That's one of the reasons why I like it, because it's live, because it's sort of live updated. Let's see here. Anybody else have any other questions? Okay. I will be providing you with some supplemental materials. I may try to direct some of I get 2 TAs this semester, right? So because there are almost 80 of you guys in this one class, I theoretically could have had one TA almost full-time just for you guys. But I wanted to try to keep costs down in the department. So even though I have some classes with 60 and 70 students in it, I still have like one TA half-time per class. But because of the fact that I have 2 TAs that have taken this class previously with me, I think they're going to be a really good resource for you guys. If we do a remote exam, obviously you have to have your proctoring stuff installed. I'll try to detail that if necessary. But pretty much everything that's going to take place, according to my understanding, is pen and paper in class for assessments, and then maybe Canvas for some quizzes and stuff along the way. Um, it really kind of depends on how it's laid out, what accessibility is, but I think everybody should be able to have access to Canvas on their mobile device. So I may do some quizzes based upon your information retention, how much you're paying attention, how much you're getting out of the lectures. I may do those as part of the class time just to keep everybody on track. Um, I have a policy on late assignments that says assignments will only be accepted within a reasonable period of time. That is very, very much true in this case. Um, the provision of being able to allow additional time is my prerogative. All right. I have no requirement. I could just say it's done. All right. Usually I'm not going to do that, but I may in certain circumstances. All right. Just depends. If you come to me less than 48 hours from that deadline, you may not receive a response at all via email. All right. I don't really like it whenever people fail to plan and then come in a short period of time with a very complex project and try to say, oh, I'll be able to get it done tomorrow. If you're coming up to that deadline and you're really feeling like you're short, okay, it may be a 20% penalty, but go ahead and get it done and we'll discuss at that point in time. I look at it and say that challenges, if you can't tell me what it was that was holding you up and you can't provide me with a specific technical challenge that was really holding you up for the implementation, then don't bother. Okay. You haven't done enough work. I want you to make sure you're coming to me prepared. If you have questions, if you have challenges, if you'd like an extension on a project, tell me specifically what was the error message that came up on your screen? What formatting problems are you having? Is it taking too long to run? Is it longer than you anticipated? Be specific, right? As what part, what module, what elements are coming into play. Show me your code. All right. Show me your code. That is one thing that I really, really don't see any reason why someone at the level that you guys are at is not capable of providing me with a repo with a link to your code with commentary and line numbers describing what your challenges are. Okay. That will make it so much easier for you, one, but it will also make it a lot more clear to me that you've done the work. If you've done the work, it makes it so much easier for me to feel like I'm justified in spending the time to try to help you on it. Okay. Because that means I'm getting something back for the effort that I'm putting out. If I'm having to lead you by the moment on each individual element in this process, I'm not going to be happy about it, partially because of the fact that I'm going to have a lot of people expecting a lot out of me in this circumstance. So try to come prepared, play your A game, and we'll be good to go there. Okay, I think we've covered all of this. I do offer accommodations for accessibility. I'm very open to that. So if you have any accessibility considerations, I'll do my best to try to accommodate you under any circumstances I can. If you have a reason to communicate with me, I am by far totally open to talking about any challenges you might have with the course or materials. From the guys that are in here that have been in my class beforehand, you'll probably find out that I am pretty accessible. I'm pretty soft on most of this stuff. I'm kind of a teddy bear sometimes. All right, but don't push me. Uh, so I'll be nice. If you're good, you're working, then I'll work with you as well. All right. Give me one moment. I'm gonna go ahead and open up. I've got a set of PowerPoint slides here. Switch to these view. Huh. Oh, there it is. Okay. Sorry, I had to change it for window here. Any questions about the syllabus or other materials there?
I
Okay.
have a question.
Oh yeah, please.
So, are we going to be going over language learning models such as things like ChatGPT, as well as like vector embedding, that kind of stuff?
So like that largely falls underneath of the natural language processing. And yes, I will have a section following NLP. It will unfortunately probably be a little truncated because the fact that it is technically a subset of the deep learning framework. It's not really like a core item, but I do consider it to be relatively important. Vector embedding and spatial embedding, spatiotemporal models, something like transformer networks. I will try to allocate like an entire week to those topics, but they can almost take an entire class by themselves. So I would say I'm going to try and take some of the stuff that's been a little heavy in the front of this class, which is a review for a lot of people, and I'm going to try to crunch it down. The further I crunch it down, the more will give me time later on in the class to expand some of that stuff. So if it's a topic that I'm finding that I get a lot of people who are interested in, um, then I'll try to expand it more. Like we'll see what's going on in that space. So I won't spend all of my time on something like CNNs and spatiotemporal convolution because I recognize that not everybody's going to be dealing in that space, like image and vision processing. It's my favorite, but at the same time, I recognize that there are a lot of other tools that are out there, especially stuff like ChatGPT. Consider though that something like ChatGPT is very cutting edge. Like it is the moment right now. It is the Geist of the analytical era. So at the same time, while I say yes, I'm very interested in teaching you about it and talking about it, it requires a lot of ladder steps to get up to it, right? It requires a lot of building of the basic principles of how those systems are put together. We will definitely get into a more in-depth analysis of transformers. And I would say that I will try to talk to you about both attention is all you need and modifications of spectral operations with attention edifice, both of those publications that will show you kind of how large scale spatiotemporal embedding systems operate with inference models for something like large language model programming. If you at some point in time after this class decide that that's an area you're really interested in, we could do something like a directed reading or whatever. Ultimately, I'd love to put together a class that does just that, right? That would be my thing at the end of this sort of chain, the sequence of development. I'd really like to see a an NLP slash like advanced AI methodology model where you're dealing with like maybe metacognitive modeling and stuff like that as well. So there is actually a class that specializes in neurolinguistic programming, Chris. So I would see maybe if I can borrow some materials from there as well and bring those over for you. So I'll try my best. Okay, I'll try my best. I know everybody wants to know how to build their own ChatGPT. We'll see if maybe we can do that, right? So depends on how well we get through this stuff. Okay, anybody else? Seriously, I'd love to hear this now because, quite frankly, we can start talking about this stuff on Thursday. If there's any other topics anybody else is interested in, I can add those to my list. First thing I'm going to add to my list on here that I'm going to do a section on GPTs.
I guess one thing for me would be diffusion. It'd be nice to touch on that because
Okay,
I have a
generative
vague
models.
understanding.
Okay.
Yeah, but like I have a vague understanding of it, but honestly, I probably couldn't really explain it. So,
Sure. That's good. I said previously this class was effectively a neural network specific course, and then deep learning sort of got tacked on to the end of it. So it starts off with neural networks, and then it gets a little bit more deep learning, and then gets a little more. So as we're working on it, so generative models, specifically, I'll do a model section on SD, and PD, procedural and stable diffusion methodologies. Yeah. Cool. So Cheyenne. Sure. Yeah. Well, this class is a lot more mathematically intensive than statistical learning. There will be requirements for proofs. So solvers and proofs. We're going to have a module discussing implementation of things like gradient Laplacians, uh, the vector algebra involving eigenvectors and eigenvalue analysis, and the matrix diffusion models, especially for back propagations. So you're going to have matrix models largely focused on how to calculate back prop. So yeah, we'll do that. It really depends on what you're looking at there. There's a difference between working with real data in the mathematical frameworks and something like the overarching conceptual framework of solving an equation or creating an equation for a larger system. So a lot of times what our focus is going to be on taking the equations, taking the models and methodologies, and then applying them specifically to feature vector characteristics for that system. So if you're looking at specific numericals, yeah, we're going to have a few 5x5s, maybe, something along those lines for eigenvector, eigenvalue analysis. You'll be doing some math in the class. As far as something like acceleration, with regard to the methodologies by which we do matrix compute, such as matrix multiplication, those kind of things, I will have one section that I'm going to bring out that is a novel methodology for matrix compute that has not yet been implemented as part of neural networks. But we'll see whether or not we do anything with that along the way. So, Samir.
Hi. Oh,
hey, what's
I'm
up?
out of the camera. Would we cover something like reinforcement learning by chance?
Yes, I planned on doing reinforcement learning. We'll talk about it with respect to its contrast with Hebbian learning. There is an interesting contrast between Hebe learning and reinforcement. And I might actually load that in a little further. We might do that a little earlier initially, and then we might sort of go back to it later on. The key challenge would be attempting to generate some sort of project with reinforcement learning could be a real problem. All right, the reason why I say that is the stochastic nature of systematic reinforcement can make one training take 3 forevers. Okay, so it's very possible you could train something basic like a car driving simulation or a bipedal walking simulation, something like that.
That's actually where I got
in a matter of a few thousand iterations, but it can get hairy. So, but I will put that in there. We'll have a section on reinforcement early on. I think there's already a section on it, but I want to expand it. So we're going to do that. By the way, this class is so cutting edge. Now I'm not saying it's like exactly bleeding edge, like out there where, you slip and cut your leg off. But this is cutting edge in the fashion to say every semester this class has to change a little bit to stay up with the times. Okay. So I'm going to be actively adapting some of the topical analysis we're doing. Some of the classes, some of the things we talk about are not going to be in the textbook. I'm going to be providing you with a paper, right? That's dealing with the topic. So that's going to be a different for some of you guys who have not done that before, where you're analyzing a paper. So we're going to stay very up to date, as much as I can do past 2020 in terms of publication timelines. Yeah, Cheyenne. That you'll have this for mathematics. Yes, there will be some homework style problems for mathematics. I'll make sure to have some special ones just for you, Cheyenne, since you seem to love them. No, I will. I know you love doing math. You won't like all these. You won't like all these. I guarantee you won't like all these. But there will be a little bit more emphasis on direct implementation and compute. I will say, in a certain sense, by the time we get up to the level of abstraction that's necessary in high level compute space like deep learning, it becomes a little bit harder to do it by hand. Like anything of merit, anything of use becomes almost impossible to do by hand, right? That's the reason why we've come to the idea of computing. It would take you so long to execute even the most remedial set of calculations by hand that it's not really worthwhile, right? So we abstract. The further we abstract, the higher level we get, right? So the language of mathematics is equations. Those equations are descriptive of processes. Those algorithms feed into our understanding of what's actually happening on the ground floor. Now, granted, yes, you can get back and track back the mathematical processes, why you say these things added together, these things divided together. It's the process of that workflow that we're really going to focus on. So a lot of this is going to be symbolic algebra, linear algebra, workflowing through those pipelines of understanding and working with the equations. Notation will be a big factor here, where we're paying attention to keeping track of what's going in and what's coming out from every node, and being able to write the appropriate subset notation on those systems, and being able to annotate models. Like I said, that will fall off quickly, right? So by the time we get up into anything that's even slightly complex, we're going to really have a love for the fact that a lot of these things have tools that will allow us to sort of automatically notate a lot of what's going on in the system. So you'll find your love for the automation of the process. Okay. Any other questions? Okay, well, thank you all for being here. I'm going to go ahead and hold off on this presentation. We'll just start and do it all at once. I'll kind of have the introduction to both the yeah. Any of you guys who've been in my ISL know that I have a love for the biology behind this. There is a bit of biology, because ultimately neural networks are effectively they're the next sort of rational step in understanding biology systems, right? So we started trying to model the brain. We learned things about modeling the brain in silica, right? So we did it on chips, we did it in these MEM-resistive systems, and then we built better tools. Funny thing about it is the better tools help us better understand the brain, and it's just been this back and forth process. So every time we think we've created something that is a really good approximation of the way humans think and is really smart and has all this processing capacity, people a couple of weeks down the road go, well, actually, the human brain is a lot more efficient than anything we've done thus far. We'll have a discussion on that in the end of this process. A lot of it is going to be dealing with the ethics of utilizing deep learning. All right. Deep learning can be used for neural networks can be used to solve basically any problem. So at the same time, we look at it and say, well, if it takes 3 times the electrical energy for a deep learning model to do it as it would for us to hire a human to do it, is it ethical for us to spend that electrical energy on that process, right? Because that electrical energy comes from some stored potential energy somewhere. We haven't figured out how to fully run the planet on solar and wind and wave power, right? So at the moment, we're really pulling from some available stored energy resource in order to be able to make that happen. So efficiency and the quality of the model, the metrics and paradigms of that model, when we're trying to understand what those metrics and paradigms mean, do ultimately track back to stuff that have ecological and environmental, sociological, and international cooperation-driven challenges. So we're going to talk about that along the way as well, right? So the ethics and processes of adaptive systems, whether we're building something that's effectively we're trying to create little digital slaves to be able to do all our work for us, or whether we're looking to build things that improve our quality of life and create better things for humanity. those two paradigms are going to come into play in the scope of the world. And you guys are the ones that, even though today you may be just learning about this, and this is your first step into development of these advanced models, you guys are the ones that are going to be making the recommendations, the policy implementations level decisions. You're going to be influencing the cultures of those companies and those organizations you go to work in. So we're going to all of us work together to be able to create a better understanding of the technology, as well as to discuss the impact that technology has along the way. So, all right, well, guys, I will see you. We are in 310 Flarsham, so I'll see you guys there. Hopefully Thursday night. I haven't looked at the forecast, but I think it should still be above zero. Probably have a little bit of time where the roads will be somewhat cleaned off. We'll see here. Thursday. Yeah, it'll be all right for us to be there Thursday, I think. Mid-20s by the time we're done with this. So see you guys all Thursday. Thank you very much for coming. And have a good rest of your starting week.
Sweet. Thank you.
Bye-bye.
Thank you.